All right, welcome back. We're going to talk about problem set 6 in this video. And these questions were also taken from the Google form responses that y'all gave me. At least one person identified these vague concepts as things they'd like to talk about. So here we go. This is question 1. We've got this wheel here. You're going to pay $2 to spin the wheel, and the amount shown is what you receive back as winnings. So for part A, it wants you to fill out the probability that you donate each of these amounts. And that's a little confusing because these numbers don't necessarily line up with what's on the wheel. The wheel is what you receive. These values are your effective donation to the cause. So if you paid $2 and the pointer lands on 0, like it is here in this picture, you've donated $2. If you land on $1, you paid $2, so you donated $1. And if it lands on the $10 wedge, you've donated negative $8 because you effectively stole $8 from charity, you monster. So we, for part A, just need to figure out these probabilities. And based on this wheel, we've got 10 wedges here. 1, 2, 3, 4, 5, 6 of them have $0. So there is a 6 in 10 chance, or 60% chance, that you donate $2. 3 of them are $1, so this is 0.3. And the remaining 1 out of 10, you donate negative $8. You win money. Congratulations. That wasn't the point of this game. So that's part A. They just want you to fill out the probabilities. In terms of the scoring, section 1 is parts A and B together. So let's actually talk about part B before we go back to the grading. So part B asks what the expected value is for this probability distribution that you found in part A. So let's assume that you had no idea how to fill out this table. As long as you made it a valid probability distribution, so like these all add up to 1, you could have made numbers up for the table and still gotten part B completely right. So from now on, let's assume that you got the answer right for this. The expected value, you take x times p of x for each of these and then add those products. So 2 times 0.6 plus 1 times 0.3 plus negative 8 times 0.1. And you end up with 70 cents, 0.70. So the expected value, they're expecting on average to make 70 cents for each person that plays the game and spins the wheel. So A and B, that is section 1. A and B are put together. You get an E for those parts put together if you fill in the table correct and the expected value is correct with work shown. You can't just say it's 70 cents because you did it on your calculator. You have to write out the formula, essentially. How did you get that answer? You have to show them. You get a P if the table's right and the expected value is wrong, or the probabilities in the table aren't all right, but the expected value is consistent, which is what I was talking about. So you can still get a P even if you get part A wrong. All right, section 2 is part C, so let's talk about C. The charity would like to receive a net contribution of $500, so hoping to raise $500. How many games do they need to be played in order to expect to get that $500? So to answer this, you need the answer to B, because if they want to make $500 and they're making 70 cents on average per game, how many games do they need to be played in order to get to $500? So you can set up a simple inequality here. 0.7 times the number of games played has to be at least 500. Solve for n. Just divide both sides by 0.7. You get 714.286. You can't round that down because 714 games will leave you just a little bit short. So you need 715 games to be played to get at least $500. Okay, so that's section 2. It's essentially correct if you have both of these two things. You give a solution based on a reasonable calculation, equation, or inequality, and you round up to the nearest integer. You need both of those. Okay, and you need to show the calculation, equation, or inequality. You can't just say the answer. Okay, partially correct, you get a P if you do the first thing but not the second thing. So even if you get the calculation part correct, if you set up the inequality and get the decimal answer, you still get a P if you don't round up to the nearest whole number. And it's incorrect if you don't do either one. So let's say you use the wrong inequality or somehow you set it up incorrectly. You're going to get an I no matter what, unfortunately. Section 3 is Part D. So Part D, based on last year's event, they anticipate that there will be 1,000 plays, which is good because you said in Part C that they need only like 700 something to get what they need on average. But let's see here. They want to know the probability of meeting their goal of $500 if the game is played 1,000 times. They give you the mean and standard deviation of the net contribution in 1,000 plays. You don't have to calculate that. That's pretty nice. This exam was given in 2012. This problem was in 2012's exam. So who knows? Maybe they would have you calculate those now, but this is already A through D. So maybe they'll give you these. $700 is the mean, and the standard deviation is $92.79. So if you're really wondering how those were calculated, you can come up with the formulas for the mean and standard deviation of a discrete probability distribution. I can tell you the $700 comes from taking the 70 cents, that was the expected value from one game, and multiplying it by 1,000. The standard deviation is a little more involved. If you want to know the ins and outs of that, I can give you that if you ask for it. But that is an exercise left to the viewer. Use the normal distribution to approximate the probability that they'll get what they need, $500 in 1,000 plays. They even tell you to use the normal distribution. So I don't want you to think that you have to check conditions for a problem like this. One, because they tell you what to use, normal. And two, because you only need to do that if you're calculating a confidence interval or doing a hypothesis test. Those are the only times you need to check conditions. You don't need to do it for questions about probabilities. So we're going to use the normal distribution to approximate this. How does that work? Well, we go back up here. Okay, so in this solution, they say why the normal approximation is appropriate. I would just say it says to do so in the problem. So if you're using the normal distribution, you calculate the z-score. So you take the amount you're interested in, that's the amount of money they're hoping to raise, $500, minus the mean, 700, divided by the standard deviation, 92.79. You don't need to divide that by the square root of 1,000. That's for t. Here we're using the normal distribution, so it's actually z. That's just value minus mean divided by standard deviation. No square root of n here. And that comes out to negative 2.155. At this point, I think it's the limitations of this format, that it's digital, that they don't provide a sketch of a curve. Once I find a z-score, I'm drawing the normal distribution curve, and I'm putting z at negative 2.155, and I want to know the probability that they obtain at least that much. So it's kind of strange because we usually shade towards the short end, but here that z-score is negative, but we're shading everything to the right because that represents all of the values above $500. So it's most of the curve. And to calculate that probability, you would probably use normal CDF, going from negative 2.155 all the way up to 9999, with a mean of 0 and a standard deviation of 1, because this is a z-score you've already standardized. And it turns out you get 0.9844. Okay, a very high probability. I want you at this point, not necessarily for the AP test, you don't have to think about this, but right now, as you're still reviewing, why is this probability so high? It's almost 1. Remember, they only wanted to make $500. But in 1,000 plays, on average, they're going to make $700. So it should be very likely that they get at least 500 if 700 is the average. And the standard deviation is only 92.79. Okay, 500 is more than 2 standard deviations below the average. So it's a very small probability that they'll come up short. Okay, I want you to be able to make sense of this number, not just calculate it. Right? And they provide an interpretation. Therefore, the charity can be very confident about getting a net contribution of at least $500 from 1,000 plays of the game. I think that statement is optional. All it asks for is an approximation of the probability. It doesn't say that you have to interpret anything in context. That being said, let's talk about how it's scored. This is part D, which is section 3. You get an E if you do all these things. Indicate the use of a normal distribution with the correct mean and standard deviation. We've seen this before. Anytime you're going to use a model, you should state what that model is, so in this case normal, with its parameters. So for the normal, you need mean and standard deviation. For T, you need degrees of freedom. For binomial, you need N and P. So you need to state that you have a normal distribution with a mean of $700, standard deviation of $92.79. Those came from the problem. Okay. You need to use the correct boundary and indicate the correct direction. So the way they do that here, they use this sentence. What you might do instead is put P and then in parentheses Z greater than negative 2.155 equals 0.9844. I would write that as a probabilistic equation rather than writing it out as a sentence, but this is fine. And you need to get the right answer that's consistent with what you've done here. Okay. It's partially correct if you correctly address exactly 2 of those 3 things, and it's I if not. Okay, so it says right here in the note, in the first note, the response does not have to justify the normal approximation or show how to calculate the parameter values. So you're off the hook for calculating these things, and you don't have to check conditions. Okay. If you earn credit for component 1, so you say the normal distribution and the right mean and standard deviation, but no direction has been provided, then you earn credit for the last one if you get the right answer. Okay, so as long as you say normal distribution, mean of 700, standard deviation of $92.79, you don't necessarily need to write that probabilistic statement if you get the right answer. Okay. If the response does not earn credit for what this would mean is you would get a P even if you didn't do this. Yeah. And if the response does not earn credit for component 1 because you did something wrong, you can still get credit for component 2 if you do it correctly. Okay, so another one of those cases, if you weren't sure what distribution to use, make something up, and you can still get credit for subsequent parts. Okay, let's see here. This tells you how many points you get from that problem based on what letters you get from each section. Okay, let's talk about question 2. Question 2. Okay. So we've got Sam, who's a frequent flyer. He's purchasing coach class tickets, and an airline claims there is a 10% probability that a person like Sam will be upgraded to first class. Interesting. Okay. Part A, what's the probability that his first upgrade will occur after the third flight? Yes. There was someone that responded binomial is something they wanted to review. So this is a binomial problem. So let's let this random variable, y, it could be x, it could be whatever, denote the number of flights he has to make until he gets his first upgrade. The random variable y follows a geometric distribution. Okay, so I lied. Technically, this is geometric because for part A at least, it's the number of flights until the first upgrade. Remember, geometric is the number of Bernoulli trials until the first success. You could also use binomial here. The probability that his upgrade will occur after his third flight, you could do it this way. What this is saying is the probability that his first upgrade is at the fourth flight or more is equal to 1 minus the probability that it's in the first 3, right? That's the complement rule. So what they do next is they take the probability that it's 3 or less and write that out. That's the probability that it's on the first flight, plus the probability it's on the second flight, plus the probability it's on the third flight. And then they figure out the probability of each. The probability that Sam gets upgraded on his first flight, well, that's 10%, right? That's 10%. The probability he gets upgraded on exactly the second flight means he didn't on the first and he did on the second. That's 0.9. He didn't times 0.1. He did. And the probability he gets upgraded on exactly the third flight, he didn't get upgraded on the first 2 and then did on the third. This is 0.9 squared times 0.1. And so they write all that out, and that ends up being 0.729. Okay, that is one way of doing it. You could use the complement rule. I think this is scored, yes. Part A, it's essentially correct if the response includes a correct probability and shows supporting work. And it also gives an alternative answer that is very small type here, so I've blown it up, or at least I can blow it up. Let's do that. Okay, I think this is an easier way of getting the answer. The probability that you get your first upgrade after the third flight is the same as the probability that you do not get an upgrade on the first 3. And to write that out a little bit more, that's the probability you don't get an upgrade on the first flight, and you don't get an upgrade on the second flight, and you don't get an upgrade on the third flight. The probability of each of these is 0.9. And since they're ands, they're multiplied together. It turns out 0.9 cubed is 0.729, which is the answer. Okay, so either way, you could use the complement rule, or you could do it this way and get the correct answer. But to get an E, it needs to be right, and you need to show how you got it. You're going to have 45 minutes to do 2 problems, so you should be able to have time to write out anything you need. You get a P for that if you do something that's wrong but close. So if you calculate the probability that he gets upgraded on exactly the third flight or exactly the fourth flight and show work, you get a P. Or if you get the right answer to the question but don't show enough work. Okay, so you can get a P even if you don't do the right thing, as long as you do that thing correctly. Note, the calculator command with no other justification should be scored no higher than P. So you can write this, but even if you get the right answer, because this is the way to get the right answer, you can use Geomet CDF. You're going to get a P. But if you label 0.1 as P, like if you put P equals 0.1 here, then you get an E. So this is the same thing that we talked about in the previous problem set. If you're going to write this calculator jargon, all you have to do to be in good shape is put the parameter in there. This is P, and the 3 is actually N. I would have included that in here as well. So put P equals 0.1, N equals 3. Apparently, those are the magic words. That shows the reader that you know what those things stand for and you're not just vomiting calculator speak. Okay. It's an I if you screw up. Part B. What's the probability that he'll be upgraded exactly twice in his next 20 flights? This is no longer geometric because it's not the number of flights until his first upgrade. This is n equals 20, x equals 2. This is now binomial. So you need to use the binomial distribution here. So they denote everything. They say that P is the probability he gets upgraded on a particular flight. X is the number of upgrades in 20 flights. X follows a binomial distribution, n equals 20, P equals 0.1. Do you have to write all this? It would be great if you did. However, I think what we really know here is that they want to see something like this. And you could write that as simply as, let me bring up Notepad here really quick. If you were to type something as simple as this and say what X represented, I think you'd be in good shape. Because that is what this is saying, but it's quicker to write, in my opinion. I'm a statistician. I don't like writing things. So I'm guessing when we get to the scoring part, they're going to say in order to get an E, you've got to write this out. You've got to say what distribution it is with the parameters. And the probability that he gets upgraded exactly twice in his next 20 flights, go ahead and write out that binomial probability model. We don't write it as 2 with a subscript of 20. We wrote it as, in parentheses, the number 20 over the number 2 with no fraction bar. 20 choose 2. Okay. 0.1 squared times 0.9 to the 18th. And I do believe that the binomial probability model is on the formula sheet that you're allowed to have during the test. And I would imagine you could even have your textbook open to the page where this is on as you do the problem for this year anyway. So calculate that out. You could use binom PDF here. I would use binom PDF. The number of successes is 2. N is 20, P is 0.1. That should give you 0.2852. In terms of grading part B, it's essentially correct. If you've got everything, you get a P if you show your work, but you make some kind of mistake in calculating. 0.12 times 0.918. I don't know why you would get that. 0.12 times 0.918. Oh, weird. That's like if you... That's kind of strange. Or if the response includes a correct probability within the sufficient supporting work. So always show your work or you're never going to get an E. Anytime you're asked to calculate something, show that work. Again, if you put in binom PDF 20.12 with nothing else, that's a P. Label these. N, P, X. Okay. If the response in part A was downgraded to P for failure, do I just... Okay, so you can only be dinged once for not identifying the parameters by doing this. And it's incorrect if you don't show any work or if you give something that is totally unreasonable. Like, if you type in something into your calculator and it gives you something greater than 1 or less than 0, don't even write that down. You should know at the very least that is not reasonable. Okay. Part C. Sam will take 104 flights next year. Would you be surprised if he receives more than 20 upgrades to first class? First things first. I would rather you leave this blank than to say something like, you know what, I think I would be surprised because 20 seems like a high number. This is not an opinion question. They want you to justify your answer using statistics. Okay, so if you're lost, I just for pride purposes, I'd rather you keep it blank than to give an opinion that doesn't have any statistical justification. Here's how it actually works. They define their parameter first. That's usually a good thing to do. They say that it follows a binomial distribution with n equals 104 and p equals 0.1. So again, you could use language like this. Now we're using n is 104. Okay, so you could write this instead of writing what's highlighted here. We want to know the probability that the number of upgrades is more than 20. More than 20. So this is not like greater than or equal to, strictly greater than. But again, if you're using your calculator, which I would recommend, binom CDF, it can't do greater than, so you've got to use the complement rule here. 1 minus the probability that it's less than or equal to. The reason this isn't 19 is because this is strictly greater than. This actually is starting at 21, right? X has to be greater than 20. So that starts at 21. So when you use the complement rule, this does become 20. Okay. So you would use binom CDF. N is 104, P is 0.1, and the number of successes goes up to 20. So that'll give you this. If you just do the binom CDF part, if you remember to do the 1 minus, that'll give you a very small probability here. Okay. My apologies. My cat is being really annoying right now. What's your problem? I beg your pardon. Anyway, and again, they write here a lot of stuff. I guess because they say justify your answer, and would you be surprised? I guess they're wanting more than just that probability. We're going to see how this is graded in just a second. But we'll see how it's scored. This may or may not be necessary, this entire paragraph. Essentially, this probability is really small. Okay. Let's see how it's scored. I'm curious. Part C. It's essentially correct if it includes an answer that is linked to a correct probability. Okay, so you could say something as simple as the probability that Sam receives more than 20 upgrades to first class during the year is 0.0014. You don't have to write any of this. Okay, so I don't want you to think you have to do that. Very simple answer there, in context. Partially correct if you include an answer and provide a justification based on expected value. Interesting. Okay. The response includes an answer to the question that's linked to an incorrect but reasonable probability. Okay, so you didn't even have to know how to do part B. Make something up that's between 0 and 1, and then write the answer based on that. And then here, the response gives a correct probability and includes a correct answer to the question, but fails to link the two. Okay, so they are saying that in order to provide a correct answer to the question, you've got to write something. You can't just put 0.0014. You have to write a sentence saying something about, is this likely, is it unlikely, based on the probability you got. Okay, I would hope that they would be more explicit in their instructions than this, but who knows. You can also get a P if you give a correct probability but don't answer the question. Okay, so if you leave that number naked and don't say anything, on this test you would have gotten a P there. So just write a response in context. This is unlikely because it says that he only has a probability of 0.0014 of getting more than 20 upgrades to first class during the year. Whatever. Okay. It's an I if you don't do that. Okay. Based on your responses, these are the possible scores. Yes, Katie, those are the possible scores. And hopefully if you did these problems and submitted it, you see my responses in how I graded it, and you can see where your strengths are and where you need to think about how you can improve. I'm hoping that by now you've done 6 of these problem sets and there's really only going to be at most one more of these. By now, you're starting to think not just in terms of how do I do this problem, but how do I craft my response to get that maximum score? Because it's possible to get the correct answer for all the questions and still not get a good score on the test. You need to know how to craft your responses. So I want you to think about that as you lead up to the test. At this point, you either know how things work or they don't. For the things you know how to do, I want you to focus on how that response is crafted. Are you getting E's when you know what to do, or are you getting P's for some reason? If you're losing points there on things you know how to do, I want you to focus on how to improve that. Okay, so we will see you in the next problem set. It will probably be the last one as your test is upcoming. Again, if you have any questions on anything, if you are panicking because you feel like there's like something you don't remember and you're scared it's going to be on the test, let me know and we'll have a nice chat. We'll talk through it and we'll make you a little more comfortable with that. But if you've been working through these, if you've been watching the videos, doing these problems, I think you'll be all right. So we'll see you in the next problem set. Have a great day.